Hello everyone, myself. In this presentation, I'll be explaining about types of wind machines and their characteristics. Like we'll be focusing more mainly on horizontal and vertical axis windmills, its elementary design principles. So what is a wind machine? It converts kinetic energy from wind into mechanical energy or electrical energy. So you can see in the image the wind turbines. Like we were from dynamo, we can either conduct electricity or we can directly use that wind energy, which is converted from kinetic energy into a mechanical energy and rotate any device which we need. The main importance of wind energy is like it is a renewable energy resource. Like we can get it as long as the air is present, and we know that air will be present for infinite amount of time until the earth gets destroyed. And also it reduces carbon footprint and it is a sustainable power generation. Like we can get the energy throughout the year. Like it doesn't depend like summer, winter, or rainy season. Also, it doesn't provide make any carbon footprint. No harmful gases or the devices won't get waste. They can be reused. So types of wind machines are horizontal axis wind turbines and vertical axis wind turbines. The one which we are seeing in the image is horizontal axis wind turbine. Like it rotates perpendicularly to the wind direction. Like if the wind is hitting it and it rotates in the perpendicular direction, 90 degree to it, and it generates the electricity or it generates mechanical energy. The selection factors for it depends on like wind conditions or site location and application and cost. If we want a cost efficient method to produce electricity, we can go with vertical axis wind turbines, like they are cheaper than the horizontal axis wind turbines. And wind conditions, if it is too windy or the wind direction is from every direction, vertical axis wind turbines are preferred. And if we have a constant amount of wind flow in a particular direction, perpendicular axis or horizontal axis wind turbines are preferred. Horizontal axis wind turbine. HIWT in short, like most common type rotor shaft and electrical generator at the top of a tower. Blades rotate perpendicular to the wind, and like you can see in the image, like the generator or the dynamo, it is present in the top of the turbine, and when the shaft rotates, it rotates the generator and generates the electricity. That electricity can be stored and it can be passed to other places for consumption. It is mainly built in the hilly regions, like there will be a lot of wind flow in that region, so it is built near the hilly regions and it requires yaw mechanism. You can see in the image like three blades are there and it rotates. The main key characteristics are high in efficiency capturing wind energy. Like it captures almost all the wind and it rotates efficiently and it provides a good amount of energy. Typically larger with higher power, but like it will be huge and it produces large amount of energy and it requires yaw mechanism as I said earlier. Vertical axis wind turbines, like you can see in the image, it is not as big as those horizontal axis wind turbines, and rotor shaft is arranged vertically. Blades rotate around a vertical axis. Like you can see the middle, and in the middle there is a rod. Around that, the vertical axis wind turbine blades rotate. So the main advantage is the direction of wind can be from any direction. It doesn't depend. Like the air should come from particular direction or something. It can be from any direction. Like the first key characteristic of it, like it is typically smaller. In the image, you can see it is not as huge and it doesn't have any big towers. It is small and compact, and it is easy to maintain and it is easy to manage. Also to repair if any faulties are there. Comparison of HWT and VAWT, like horizontal and vertical axis wind turbines efficiency. Horizontal axis wind turbines are more efficient due to better aerodynamics. Like we can see, all the air is captured and it rotates effectively. But in the vertical axis wind turbine, if there are two wind directions and the shaft won't rotate properly, so it is not much efficient. Complexity. HLability has more complex mechanisms, yaw control and all. And VAability is simple. We can see that there was a simple rod and the dynamo was present on the ground. It rotates easily. Maintenance. Wearability is easy to maintain due to accessible components. It is not so big, so it is easy to access and repair. If you have to repair HWT turbines, like it takes a lot of complex steps to do that. Installation, HWT requires higher towers and stronger foundations. Like the wind speed will be very high, so this foundation should be built very strongly. Elementary design principles for HLFBT. Blade design. Aerodynamic shape for maximum lift and minimal drag, and total tower height. Taller towers access higher wind speeds, increasing energy capture. Materials. Lightweight, durable materials like fiberglass or carbon fiber are used so that it doesn't produce any carbon footprint. Yaw mechanism is used for rotor rotation and how the rotor functions. Elementary design principles for wearability. Blade design curved blades to harness wind from any direction, shorter and sturdier, often no cover needed for small models. Durable and weather resistant materials such as aluminum or composites. Some designs incorporate mechanisms to aid self-starting in low wind speeds. And advantages of both of them is higher efficiency in HRability, larger energy output because it is too big and it produces large amount of electricity. And the main disadvantage is it is a complex structure, like building it takes a lot of time and takes a lot of capital. There is initial cost to build that, and noise. It produces a lot of noise when the shaft rotates, and it is a visual impact. Wearability advantages are simple, like we can fit in any place and where the wind flows easily, and it is only directional, like it doesn't depend from one direction the wind should come. It is easier to maintain also. Wearability disadvantages, it is low efficient, it doesn't produce much energy, it depends on the wind direction, and it is less developed due to its disadvantages. So in conclusion, both HIability and VAWT have unique advantages and suitable applications. Design principles, like understanding basic design principle helps in selecting and optimizing turbines for specific needs. Thank you for watching. Please like the video.